everyone again and welcome back to my channel. For this video today, we'll talk about the topic 1 and the last subtopic 1.6 part 2, where in this part, we'll discuss the type of reagents and also the types of organic reaction. For the type of reagents, we have 3 types of reagent. We have free radical, electrophile, and nucleophile, and what makes them different. As a summary, free radical is species with an unpaired electron. If you remember, your Cl with a single dot, your Br with a single dot, alright, your hydrogen with a single dot. That is all your free radical. While your electrophile is the species with electron deficient. Electron deficient means losing electron, alright? Losing electron means what? Means positive charge. Your electrophile most of the time will be the positive charge species, ion, or sometimes it also can be your neutral species. But your electrophile is always the species that have not enough electron, your electron deficient. The example can be your H positive, your C positive carbocation ion, all this is your electrophile. Your Br2, your Cl2 also can be your electrophile. While for the nucleophile is the electron-rich species. What is meant by electron-rich? Electron-rich means I have a lot of electron. When you have a lot of electron means you are holding negative charge. Alright, negative charge species. For example, you have your OH minus, you have your C minus carbanion, that is all your nucleophile, your electron-rich species, okay? So these are the type of reagent that we will go through one by one. We'll go through each and every one of them in details. So first and foremost, let's start with free radical. What is actually free radical? Free radical is the species with an unpaired electron, as we everybody know, like Cl dot, Br dot, all that with an unpaired electron, okay? Your CH3 dot, that is your free radical of your methyl. It will be formed from homolytic cleavage that you have learned in your 1.6 part 1 video, your homolytic cleavage that need the presence of UV or sunlight. That is your free radical. Well, next, what is electrophile in details? Electrophile is the electron deficient species. Electron deficient species means you have not enough electron. Not enough electron because you have just loses electron. That is what we mean by electron deficient species. Therefore, it will be electron pair acceptor or electron loving. What is meant by that? When you are not having enough electron like C positive, like H positive, very simple electrophile. When you don't have enough electron, you always willing to accept more electron because I'm not having enough. When you have not enough money, you are always willing to accept more monies. Alright, so when you are positive charge over here, when you don't have enough electron, you will always be the electron loving guy. You will love the electron. The species can be neutral or can be positively charged. Positively charged is the most obvious electrophile. And because this species is a positively charged or a species that have not enough electron, this species will always attack a site that have a high electron density, normal. When I'm not having enough electron, when I'm holding a positive charge, so I will always willing to accept electron, right? Because I'm not having enough electron. And at the same time, if I'm not accepting electron, I will always go and attack the high electron density area because I'm not having enough electron. So the positive charge over here will always attracted to the negative charge. Very simple concept over here is the positive always attracted to the negative later on will be always attracted to the positive. Okay? So this is the example of my electrophile. You can see over here, the first electrophile that we can have is cation. Your cation can be your H3O+, can be your NO2 positive or the positive charge, alright? All your positive charge will be your electrophile. Your carbocation also your positive charge, that will be your electrophile. The neutral example is your Lewis acid, which is your AlCl3, your BF3. That are your incomplete octet. So your incomplete octet means they are not having enough 8 electron around it. So when they are incomplete octet, they are not having enough electron around the central atom, so it will be categorized as electron deficient species. Species that have not enough electron. So it will be under electrophile. Your oxidizing agent, Br2Cl2, also your electrophile. And the electrophilic site that we are talking over here, the electrophilic site means the partially positive site. Partially positive over here means you have not enough electron. Again, electron deficient. So the partially positive over here is my carbon that partner with oxygen. Because oxygen is very electronegative, so oxygen become partially negative. Automatically, carbon become partially positive, that we call as electrophilic site. You have your carbon over here as a partially positive. When you have your X can be your fluorine, chlorine, bromine, and also iodine. So when you partner with your halogen, your carbon also become partially positive, also become your electrophilic site. When your carbon partner with oxygen, your carbon also become partially positive as an electrophilic site. So bear that in mind, electrophile means you are not having enough electron and you will love electron. Alright? You love electron because you are not having enough of them. Okay? Next, I have nucleophile. So what is nucleophile? Nucleophile is the vice versa of electrophile. Nucleophile is an electron-rich species. You have a lot of electron. You are very, very rich with electron. In the other words, you will normally be negative charge ion. Alright, all your anion will be nucleophile, your electron-rich species. And when you are very rich with electron, you will then tend to donate the electron. Why you will be donating the electron? Because you have a lot. When you have a lot of money, you don't mind donating your money. Okay? So that is what we mean by electron pair donor. Because you have a lot of electron, so feel free to donate the electron. And why I say it's a nucleus loving? Because in the nucleus, you have proton. And proton holding positive charge. Why your nucleophile will love the nucleus? Alright? Because in the nucleus, there is proton. Proton holding positive charge. Nucleophile is negative charge. Negative always go for positive. Remember that. So your nucleophile will be nucleus loving species. Okay? As always, it can be negative charge, of course, because you have a lot of electron. But at the same time, it also can be neutral, like your electrophile just now. And this electron-rich species, alright, this electron-rich species will go and attack a site with a low electron density. Why? Because I'm already negative. So when I'm already negative and I want to attack or be friend with someone and I want to go and find someone, I will always find the one have low electron density. Okay, because I have plenty. Why do I need to find someone that already have a lot of electron when I myself having a lot of electron? So when I myself having a lot of electron, the nucleophile will always go and attack the lower electron density, which will normally be your positive. So can you see that? The negative will always be friend with the positive. Positive attack negative. Negative attack positive. So positive and negative will always be friends. Okay? So always remember, when you want to attack, when you are negative, you always attack positive. When you are positive, you always attack negative. Remember that. Okay? These are the example of nucleophile that I can give to you. The anion and also the carbanion that you can have over here. all your negative charge ion. All your negative charge ion, your Cl minus, your Cn minus, your C minus, all that will be your nucleophile. Your electron rich. You're very rich with electron. That's why you become negative charge. Your Lewis bases will also be your nucleophile because all this structure having lone pair. If you remember lone pair is pair of electron that does not involve in bonding. So when you have lone pair, guys, lone pair means you have extra electron that are not in the bonding. You have extra electron that are not in the bonding. So the extra electron will cause the species to become very electron rich, very high electron density. Okay? And your nucleophilic site will be those that holding multiple bond, like your double bond, your triple bond, and also your benzene. Your benzene is a 6-carbon ring with double bond alternate each other. So that is your benzene. And they are nucleophilic site. Why are they rich with electron? Guys, one bond is 2 electron. So that is normal. Double bond means 4 electron. Very rich. Triple bond means how many electron? Triple bond over here means 6 electron. Rich plus rich. Extremely rich with electron. Okay? So double bond, triple bond, and also your benzene is your nucleophilic site. Or we would say an electron-rich site. Okay? Simple. Next, let's go into type of reaction. We have 3 types of organic reaction that we will look into. The first one is your substitution reaction. The second, we have addition. The third, we have elimination. Substitution over here means replace. Do you understand the word replace? Replace means you have 6 square. Alright, for example, you have 6 square. And I want to replace one of the square with circle. So what do? The 5 square remain unchanged. But one of the square need to remove. You need to remove this, then we substitute with the circle. Alright? So that is what we call replace. Replace or substitute means the total amount at the end is not changing. The total amount is still 6. But we are changing by removing it and then replace it. Okay? That is what we mean by substitution. How about addition? What is meant by addition? Addition means you add in. Alright? You add in, you top up. Alright? You add extra. In the other words, if I have 6 square over here from the beginning and I want to add a circle, I only add. I do not need to remove anything. I will still have the 6 square in there. And what do? Is I add a circle. So can you see the difference over here? In the addition, we do not need to remove anything. We do not need to remove anything. We only add in the things that we want to add. Okay? And you can see the changes. Over here is 6, over here is 7. When it's an addition reaction, the number at the end will be different. The number at the end will be increasing. Okay? Well, last but not least, we are going to talk about elimination. Elimination means we are going to remove. Alright, we are going to remove only. We are not going to do anything else. We are not going to add in anything else. Remove means I might have 6 of them. Alright, 6 of the square. And what do? We do a reaction and I remove one of it without replace or add in anything. So you can see that the number is changing from 6 to 5. Okay, so the elimination reaction is only going to remove what you want to remove without adding in anything or without replace with anything. And that is what we call elimination. And the keyword that we can use, substitution means we are going to replace, addition means we are going to add them up, elimination means we are going to remove. Keep that in mind. Alright, this is the most basic in the type of reaction before we go in deeper. We start off with substitution. We have 3 types of substitution over here. The first one is your free radical substitution. The second, we can have electrophilic aromatic substitution. Last but not least, we can have nucleophilic substitution. Why are we having different name of this substitution? Free radical is the keyword for this free radical substitution, means the person that doing the changes, alright, the person that doing the replace is your free radical. Alright, free radical will be the species that replace in this reaction. That's why it called free radical substitution. Electrophilic aromatic substitution. Obviously, electrophile is used in this substitution. While nucleophilic substitution, obviously, nucleophile is used in this substitution. The name given is the person that making the changes. When I say electrophilic aromatic substitution, means electrophile will replace something. Alright, it will replace something in your reaction. Nucleophilic substitution means nucleophile is the thing that will replace anything in your reaction. Okay, so bear that in mind, the name is given by the person who doing the changes. Okay, so let's see what is your free radical substitution stand for and so on. The first one, free radical substitution. Free radical will be as the intermediate species. In the other words, free radical will be used in your replacement. Alright, we are going to replace it, remember? It involves homolytic cleavage. Of course, anything about free radical will definitely involve homolytic cleavage. And that is the example. So let's see what is being replaced. The free radical is produced by this halogen, your Cl2, because Cl2 over here will undergo homolytic cleavage. Alright, like this. So you will form a Cl free radical, okay, due to the presence of UV. And what is being replaced? Look at the changes. The first CH3 has no changes, but the second CH3 having changes. So I'm going to expand this second CH3. The first CH3 just sit there nicely doing nothing. The second CH3 means I have something like this. The first CH3 doing nothing. The second CH3 is this. Look at the changes that happen. This CH is substituted by the Cl. Why I use the word substituted? Because the number of bond is the same in carbon. Carbon having 4 single bond over here. Carbon having 4 single bond over here. The rest of the person remain unchanged. CH3, H, H. CH3, H, H. Nothing else changed. But the seat of the hydrogen sitting here, and the hydrogen is now being replaced by the chlorine. Can you see that? So it becomes a substitution. And what type of substitution? Is a free radical substitution because you have the presence of Cl2 and UV. Cl2 will undergo homolytic cleavage because Cl2 is a non-polar bond. Alright, Cl2 is a non-polar bond with same electronegativity where it will break like this. Half-headed arrow, half-headed arrow. So chlorine will become a free radical. When chlorine becomes free radical, it becomes free radical substitution. Okay, I hope you can see that it's a substitution and it's a free radical substitution. Always remember, substitution means replace. Replace or substitution can happen when one person needs to go out and another person come in. That is your substitution. Next, we go for electrophilic aromatic substitution. Alright, aromatic definitely is the presence of your benzene ring. So let's see. Involve aromatic compound, like I said, your aromatic compound, benzene ring. Your benzene ring having a high electron density because you have a lot of double bond over here. So it's extremely electron rich. Okay. Thus, it will attack by electrophile. Why the benzene ring will attack by electrophile? Because electrophile is electron deficient. Electron deficient means you don't have enough electron species. When you don't have enough electron, you will automatically be electron loving. You don't have enough, so you will love electron. And look at the benzene ring. The benzene ring is extremely rich with electron. So who will go and attack the benzene ring? The electrophile. So let's look at the example of electrophilic aromatic substitution. That is my benzene ring, and this benzene ring is electron rich. And this electron rich is what we call nucleophilic site. Alright, very rich with electron. And the person that making the changes right now is Br. Br is making the changes. As you can see over here, the hydrogen is substituted by the Br. Alright, the hydrogen is replaced by the Br. So who is making the changes? Br is making the changes. And like I always say, the names will goes to the one that making changes. And when benzene is electron rich, Br automatically is electrophile. Alright, Br over here will be electrophile. Br electrophile replace hydrogen. So it becomes electrophilic aromatic substitution. The person making the changes will be the person naming the type of substitution. Make sense? Next, we have nucleophilic substitution. So nucleophilic substitution, obviously, nucleophile will be the person making the changes. Okay? It will be initiated by the nucleophile, like I said. And this is my example. Look at this. What is being substituted over here? Your Br is substituted by OH. The rest of the thing remain unchanged, guys. CH3, CH2, CH3, CH2. OH is the one that making changes. Or in the other words, OH is the one that replace Br. So when OH is the one that replace Br, OH will get the name of the substitution. OH is a negative over here, therefore OH is a nucleophile. And the name will be nucleophilic substitution. Alright, simple. Nucleophile. What makes phile and philic different? Phile is the name, is the noun or the name for the species. Alright. Philic over here, nucleophilic substitution. Philic over here is the name of the process. So phile is used when you are naming the species. Philic is used when you are naming the process. Don't do this mistake. Alright, make sure you know you are writing the name of the species or you are writing the name of the process. And that is your nucleophilic substitution because OH minus the nucleophile is substituting the Br. So you have a substitution process and the substitution process is made by nucleophile. So nucleophilic substitution. And next, we are moving to addition. So we have two types of addition. We have electrophilic addition. We have nucleophilic addition. As we all know, electrophilic addition means the person that initiate this addition will be electrophile. Electrophile will be the person initiate this addition. While for the nucleophilic addition will be nucleophile that making the changes. Always remember one thing, the person that making the changes will be getting the name. Alright? So let's look at the example of electrophilic addition. It must be initiated by an electrophile. It will attack a nucleophile site because your electrophile is electron poor. Alright, electron poor means not enough electron. So when you don't have enough electron, you will always need to attack an electron-rich site. Okay, that is the rules. When you are positive, you always attack negative. When you are negative, you always attack positive. And this will normally happen to unsaturated compound. Why? Because nucleophilic site is your carbon-carbon double bond and also carbon-carbon triple bond. That are the nucleophilic site. That are the electron-rich site. The area that are very, very saturated, very, very rich with electron. That is your double bond and triple bond. Let's look at this example. First and foremost, we have the presence of double bond. The double bond over here, that is your electron-rich area. And this electron-rich area, we have a name. We call it nucleophilic site. Alright, area that are very rich with electron. And look at the changes that happen. The changes happen at this double bond, this 2 carbon, and this 2 carbon right now losing the double bond with extra Br. And it's an addition because the CH remain, the CH2 remain. Can you see that? The CH is there, the CH2 is there. Did you remove anything? No, we did not remove anything. The hydrogen is still there. The same number of hydrogen is still there. And your job is only adding the Br in, adding the Br in. That's why this is only your addition. Can you different addition and substitution right now? Substitution, you need to remove something and then you replace. Addition, nothing changed in there except you have new friend. Alright, the rest of the thing remain the same. So who is making the changes right now? Br is making the changes. And Br that making the changes, Br is your electrophile. Alright, Br is your electrophile. And since Br as an electrophile making the changes, therefore, the process name will be electrophilic addition. Makes sense? Alright, see that? Your negative side will always attack by a positive side. Okay? Nucleophile means negative, electrophile means positive. Electron rich will always attack by the electron poor. Positive always attack negative, negative always attack positive. Okay? Another addition that I can have is nucleophilic addition. It will initiated by a nucleophile, of course. It will attack an electrophilic site. Nucleophile means electron rich. Electrophilic site means electron poor area. So, this electron rich person will always go and find the electron poor area. And it will normally happen to carbonyl compound. Why it will normally happen to carbonyl compound? Because carbonyl compound is a C double bond O, where the carbon will be partially positive and the oxygen will be partially negative. And this partially positive carbon will be your electrophilic site. Alright? And the nucleophile will attack this electron poor area. Let's look at the example. So this is my carbon double bond O, my carbonyl compound over here. This is the after the reaction, the double bond O is now become single bond OH. And we have new addition. It's an addition. Why I say it's an addition? CH3 on the left and CH3 on the right remain unchanged. The carbon holding that oxygen and that oxygen is still here. Means that nothing is being removed. So we only add in new friend. That's why it become addition. We add in new friend only. And why is that a nucleophilic addition? Simple. Because this C double bond O, your carbonyl, your oxygen will be partially negative due to a stronger electronegativity. Oxygen have a higher ability in pulling electron. So oxygen become partially negative. Carbon become partially positive. And look at who is our new friend. Your Cn is our new friend. Alright, Cn is the new friend over here. And the Cn is from the HCN. HCN. Obviously, H plus Cn minus. And who is making the changes? Cn minus is making the changes. Cn minus, over here is a negative charge N ion. Your Cn minus will be nucleophile, the name of the species. So when this nucleophile making changes, that's why it become nucleophilic addition. Okay, see that? First and foremost, you need to know whether they are addition or substitution. Make sure you can see clearly whether it's being added or whether it's being replaced. Very simple, focus only on the changes part. Alright, focus only on the part that have changes. And then you identify who making the changes, whether it's free radical electrophile or nucleophile. The person that making the changes is always the person that get the name. Simple. Last but not least, and the simplest, is your elimination. Elimination means remove. We are going to remove only, alright? Not going to replace with anything. Elimination happens when you have atoms or group of atoms that remove from adjacent carbon. Adjacent carbon means carbon that next to each other. Alright, adjacent carbon means next to each other. Alright, that is what it means. Alright, not the far away carbon, just right next to each other. Okay, form a multiple bond as a product. After you remove something, you always form a double or you always form a triple bond. Double or triple bond depends on what are you removing. Therefore, the double and triple bond will be counted as unsaturated compound. So you will form an unsaturated compound. Let's look at some example of elimination. Look at the changes. Look at where the changes happen. The changes happen at OH is gone. Alright. And look at the number of hydrogen. Hydrogen over here is CH2 only. Hydrogen over here is CH3. If that is not clear, let's expand it. You have a CH3 over here. CH2 and a OH. While your product only having a CH2, double bond, a CH2. Look at the changes that happen to both of these carbon. Identify the changes happen at both of these carbon. So the first carbon is loses one hydrogen. The second carbon is losing OH. Can you see that? The hydrogen and the OH is gone and become double bond. Can you see the changes? So OH is being removed, hydrogen is being removed. And in elimination, like I said, we only remove things. So after you remove, the H and the OH become H2O. Alright, and in the structure, you are losing the H and OH, and that is elimination. So like we say just now, the product will be unsaturated. Alright, the product will always contain multiple bond like carbon-carbon double bond or carbon-carbon triple bond. Simple? Alright, and that's it about type of reaction. You have three types: addition, substitution, elimination. Just make sure you know how to differentiate them. Make sure you know how to identify the changes. Just one kind reminder. If you cannot identify the changes, it's easy. Expand your structure. Expand the structure and identify the changes happen at which carbon. If the question gives you condense, don't use the condense only. Expand it so that you can see clearly the changes is what, and the changes is whether addition, you add in something new, or it's a substitution, you remove something and then you replace with other things, or it's an elimination where you only remove the thing. Okay? And it's very simple. Don't think too much and don't make it complicated. Okay? And if you still have any question about type of organic reaction, drop me a question in the comment below and I'll get back to you as soon as I can. And I hope this video helps you, and I'll see you in the next video. Thank you for watching. And don't forget to give me a like and subscribe to my channel.